In this video, we will walk through handout number 5, which is a couple of word problems, applications, that apply systems of equations. The first step is going to be to read the problems and understand them. I'm going to understand the problems better by making a little chart of all the information that's given. And then from that information, we need to write a system of equations. Here's what the two problems look like. This is what our sheet looks like. And remember that when you submit your work, you'll need to type in the answers on Blackboard, but in addition to that, you will be asked to submit a scan of your written work. So you may save yourself some time by writing out the work neatly now for these two problems, and then you'll be set and ready to go for submitting the work electronically later on. As I mentioned, I'm going to start by understanding this problem through creating a table. It's simply organizing the information for myself. Here's how we'd go about doing that. I'm going to read the problem. Awesome Alexander Furniture Factory has 1,950 machine hours available each week in the cutting department. So we've got 1950, oh, sorry, excuse me for that. Let me switch really quickly here to a highlighter. 1950 machine hours in the cutting department. So I could put that 1950, here is the total. Switch colors here. 1490 hours in the assembly and 2160 hours in the finishing. So I'm going to start by putting those three numbers in these three blocks, and then I can go through and see for a chair how many of each of those hours, for a cabinet and a buffet how many of each of those hours is required. Let's see if we can pull that out. Manufacturing a chair requires 2/10 of an hour cutting, 3/10 of an hour assembling, and 1/10 of an hour finishing. A cabinet requires 5/10 of an hour cutting, 4/10 of an hour assembling, and 6/10 of an hour finishing. And then a buffet requires 3/10 of an hour cutting, 1/10 of an hour assembling, and 4/10 of an hour finishing. Let me get these numbers written in. It's nice to highlight them in the problem, and then it's easy to pull them right out. I'm going to give you just a moment to copy this, and then after I've copied this, I'm going to go back over the problem and just double check that I've written everything correctly, because you know this is a pretty involved problem. If there's an error here at the very first stage, then my entire process will have been a good practice, yet at the same time be completely wrong. So I want to double check my work each step along the way. I've checked that and it does all seem to check out. It looks like these are the correct amounts. I've put a typed in chart here for you to see it even more clearly if you were still copying that. And then the next step is going to be to pull from each of these three areas, the cutting, the assembling, and the finishing, pull out equations. So I've got equation 1 is the cutting. I've got that highlighted orange. Equation 2 is the assembly. And then equation 3, I've got that highlighted in blue, is the finishing. I'm looking at this, seeing all these decimals, and it's so easy to make a mistake with a decimal as I get going, and this is going to be a somewhat involved process. So right off the bat, I could eliminate those decimals by multiplying the entire equation by 10. Now, if I multiply the entire equation by 10, I'm not changing the connection or the relationship from one side of the equation to the other. So as long as I do it to both sides of this equation, it's okay to multiply everything, both sides, by this number 10. And by doing so to all three of the equations, which I don't have to do it to all three, but all three do have that decimal in the 10th place. So by doing that, I'm going to eliminate some of the potential for an error working with decimals. And do you agree with this, that this 2x plus 5y plus 3z is so much easier to work with than the 2/10 of x plus 5/10 of y plus 3/10 of z? Those equations are rather tense, right? Ha, did you get my pun? 2/10 makes it 2/10. Okay, well, let's go on because I'm not hearing anyone laugh at that joke. All right, so we move on to the next step, which is to gather those equations together. Here they are. All I've done here is written those three equations. And before I go on from this step, I'm going to double check that I've written them carefully and correctly. And I checked it and it does map out. It does seem to work. Now, let me give you a little tip here. Are you seeing my x's and y's and z's as being a little bit curvy? The reason I'm doing that is if I write 2x and 2y fast, if I'm making them a little bit curvy, as you see here, it's still very distinct that my x is an x and my y is a y. If I'm not making them curvy, do you see how when I make my y pretty quickly, ooh, I'm looking back at that thinking, wait a minute, was that an x or was that a y? But if I'm always in the habit of making my y curvy or cursive, then it never starts to look like an x. For z, you could write the z curvy also, but I think for me it works even a little better to write the z with a line through it, like you see here. So that's just a free bonus tip for you. As you're doing this work with systems of equations, you might also find that little tip to be helpful. Maybe you write very, very neatly and this isn't going to be an issue for you. But if you've got messy handwriting at all, I'd recommend making your y curvy and marking your z with a line through it, or just make all the letters x, y, and z a little curvy, something that you can always distinguish your x's from your y's from your z's. But anyhow, let's move on to the first step at solving this system. What I'm going to encourage you to do is look at this process, not for a set of, okay, what's the next step, but instead look at this as, what am I trying to accomplish? Really, what I'm trying to accomplish is I want to chisel these equations down to have only one variable. I've got 3 variables in here. But if I could chisel it down to get down to only having one variable, then I'm going to be able to work backwards through these equations and get a solution for all 3 variables. So here's how we go about doing that. We look for one variable, x or y or z, to eliminate. Now, I'm going to choose x. You could choose any of them, but here's why I'm going to choose x. It's right here. And I could have equally chosen z, but if there's one variable that has a coefficient of 1, that's a good target. I'm going to choose to eliminate the x's, and you could think of it as I'm going to bounce off of this equation 3 to eliminate equation 1 and then eliminate equation 2. Here's how we do it. And first of all, let me show you how we note what we're doing as we do it. What I'm going to do is I'm going to multiply equation 3, what's this one? I'm going to multiply equation 3, x plus 6y plus 4z equals 21,600, by -2. Why did I get a -2? Because I want it to be the opposite of the coefficient of x in either equation 1 or equation 2. Since I'm starting with eliminating in equation 1, I'm going to use a -2. So I'm going to multiply -2 by -2 to times equation 3 plus 1. Negative 2 times x plus negative 2 times 6y plus negative 2 times 4z gives us negative 2x plus negative 12y plus negative 8z. And then I also have to multiply the 19,500 by negative 2. And I'm going to get negative 43,200. What I'm going to do with that new equation is I'm going to add that to equation 1. 2x plus 5y plus 3z is going to equal 19,500. And I can then add these two equations together to eliminate the x's, because negative 2x plus 2x, the negative 2 and the 2 cancel each other out. Negative 12y plus 5y gives me negative 7y. Negative 8z plus 3z is negative 5z. Negative 43,200 plus 19,500 is negative 23,700. And there we go. I've got a new equation 4. We're on our way towards resolving this system because we've chiseled away one of the variables. Which variable did we chisel away? We've chiseled away our x, right? We've chiseled away our x by using equation 1 and 3. As I go to the next step, I don't want to just be haphazard. Since I've chiseled away the x using 1 and 3, I now need to chisel away the x using 2, equation 2, and one of the other two equations. Well, the 3 was the easy one, the one that had an x that had a coefficient of 1. So now I'm going to bounce off of this equation 3 to chisel away the 3x. When you see that, are you recognizing what you'd want to multiply equation 3 times? You see I want to multiply it by a negative 3. If I multiplied that whole equation, let me show it to you like this, rather than scribbling over it. If I multiply that whole equation by negative 3, what's going to happen is the 3x minus 3x is going to cancel out again, and I'm going to be left with some amount of y's plus some amount of z's equals some constant. And I've got a y and a z and a constant for two equations. So what I will have done is I will have gone from 3 equations and I will have chiseled it down to having only 2 equations. So let's continue that. And you see the work here. I'm taking the negative 3 times that equation 3, and that's where I get negative 3x minus 18y minus 12z equals negative 64,800. And I'm going to add that to our equation 2. 3x plus 4y plus z equals 14,900. And in doing that, I'm going to get a new equation 5. Do you see how I've chiseled out the x? The x is gone. I've got a new equation 4 with only 2 variables and a new equation 5 with only 2 variables. And now I'm nearly done because all I need to do is eliminate either the z or the y. There's a number of ways we could do this, but I'm looking for any 2 numbers that have a common factor, any 2 coefficients that have a common factor. And I'm seeing that here with that negative 7 and negative 14. Negative 7 times 2 is negative 14. So if I did that, negative 7 times negative 2, I'd get a positive 14, which is going to allow me to cancel the y's. Here's what that's going to look like. If I take my new equation 4, here it is, negative 7y minus 5z equals negative 23,700, and multiply that by negative 2, it changes to 14y plus 10z equals 47,400. And then I'm going to add to that our equation 5. That was our new equation from the last page. And when I add those, look at what happens. I cancel out the y's and I'm left with a z. So I have that z is equal to 2,500. And that's it. I've got a known constant. I could write this in that z is 2,500. I know that z is going to be equal to 2,500. Next, I can use what's called back substitution to find the y. So I take the z and plug it in to either equation 4 or 5. I just took 4 because it seemed a little easier. Plug in that 2,500 for z, and I, by doing that, eliminate the z, and I'm down to a y. Now I have y is 1,600, z is 2,500. I'm just missing x. I'm going to now go back to any of the original 3 equations and substitute the y and z in to get x. Might as well take this x plus 6y plus 4z equals 21,600, though I could have used any of the equations. I'm going to choose this one. And when I do that, I get that x equals 2,000. And that's it. You could double check each of those answers by substituting in the 2,000, the 1,600, and the 2,500 and verifying that those values do in fact work. Are you ready to do the same process with number 2? We're going to fill in the chart with the information we need. And let's make sure everyone can pronounce these really cool places. Kalamazoo. Yes, there really is a Kalamazoo. A knitting shop orders yarn from 3 suppliers in Kalamazoo, St. Charles, and Haleiwa. Has anyone been to Haleiwa? Beautiful little town on the north shore of Oahu in Hawaii. And actually, I highly doubt that one bit of property in Haleiwa is going to be a knitting shop, because that property has too high of a value. Maybe a surf shop or a shave ice shop. But anyhow, Haleiwa, Kalamazoo, and St. Charles. 1 month, the shop ordered a total of 100 units of yarn from these 3 shops, or these 3 suppliers. The delivery costs were $80, $50, and $65. So 80 from Kalamazoo, 50 from St. Charles, 65 from Haleiwa, and the total delivery cost is $5,990. So if the amount ordered is X for Kalamazoo, Y for St. Charles, and Z for Haleiwa, the total cost is going to be 80X plus 50Y plus 65Z will total up or equal 5,990. Do you see that equation that we can write? Here's another equation. X plus Y plus Z is going to total up to the 100. Let me show you that printed out. Oh, I don't know what just happened. The graphic has just disappeared. So give me just a minute to fix that. Okay, sorry about that technical error there. I'm not sure what's going on. But here we have the charts filled out, And then you can see to the right, I've got a green equation, x for the amount ordered, x plus y plus z equals 100, and a pink equation for the total cost, 80x plus 50y plus 65z equals 5,990. Well, here's an important piece of information you need to recognize. 3 unknowns, an x, y, and a z, means that we need 3 equations. And I am seeing a problem here. Are you seeing the problem? We have 3 unknowns, so we need 3 ways that those equations relate, or that those unknowns relate to one another. And we only have 2. Here they are, equation 1 and equation 2. I'm going to give you just a moment to think about that. Go back to the problem, and I apologize, the problem is missing from this page. It was right here. Think through that. Do you see it? I've highlighted it in blue in the problem. The shop ordered the same amount from Kalamazoo and Haleiwa. So what does that tell us? That tells us that x and z, the amount ordered from Kalamazoo and the amount ordered from Haleiwa, are equivalent. So that third equation that we needed was x equals z. I'm going to leave the solving of this to you, but let me just help you get started, because this one will be much easier than that last one. Because we've got this easy x equals z, all I'm going to do is I'm going to go into each of these equations that have a z and replace those z's with x's. And by doing that, I'm going to get a new equation 4 and a new equation 5. And now I have 2 equations with 2 unknowns. You could then use the elimination process. So for example, I'm going to see that this y would be a nice value to bounce off of. And so if I multiplied this equation 4 by a negative 50, I could then eliminate the y's and then use back substitution to solve for x. I hope that this video has helped you get started on this activity. If you do need further assistance, please reach out to me. I'm happy to help you further. And don't forget to submit your work as well as typing in your answers to Blackboard.